All right, guys, I'm going to go over a couple of these questions so that you guys can have, quite a few examples to see how to use the point slope formula. So I'm going to do two questions of parallel lines, and I'm going to do two questions of perpendicular lines so that we can gain an understanding on how to use this. So the point slope formula is y minus y1 equals to m times x minus x1, right? So for this equation, we have a point C, which you have x1 and y1, right? Our x1 is 3, our y1 is 5. So we have an equation. So I always just, hey, what's my x1? 3. What's my y1? 5. And what's the slope that I need to use, right? So here we have a parallel line, so we're going to use the same slope. So we're going to have -2. So we have y minus 5 equal to -2 times x minus 3. From here, I distribute the -2 to both sides, and I'm left with -2x plus 6. The reason why it's plus 6 is because the -2 times the -3 will give me a positive 6. Then I want to add 5 to both sides. And my new equation is y equals to -2x plus 11, right? So as I go ahead and answer the question, I'm going to literally type that in. They're going to say nice work. So I'm going to do a similar question so that you guys can see and understanding of it. All right. So with this new question that we have a new set of x1, y1, and a new slope. So our x1 here will be 1, our y1 here will be 8, our slope here will be -4. Since we do have parallel lines, then we know it's going to stay the same. So our y1 will be 8, our x1 will be 1, our slope will be -4. So we're still going to distribute the -4 to the x and the -1. So I have -4x plus 4, right? I'm going to add 8 to both sides, and then I'm going to end up with a -4x plus 12. So as I go ahead and type that into the equation, y equals -4x plus 12. Again, another reason why I like to give you Solid's realized work, because you can just keep hitting similar questions so that you can gain a better understanding on how to answer these questions. Now let's move on to perpendicular lines. All right, now find the equation of slopes of perpendicular lines. We're going to write down the same information. We're going to approach it the same way. However, we're just going to know that we need to use the negative reciprocal, right? So our coordinate point, our x1 is 8, our y1 is -5, our slope is 1/2. Since this line is perpendicular, then I need the negative reciprocal of that. Negative reciprocal of 1/2 will be a -2. So then I put in my y1. My y1 is negative, so I had to write +5. My x1 is positive, so it's 8. So now here I still do the same thing, still distribute. So -2x plus 16. We got +5. So now we subtract 5 from both sides, and our equation we end up with is -2x plus 11. So now we go ahead and type that into our answer. Y is equal to -2x plus 11. All right, and let's do one more of these. All right, so that we remember our process for each equation, each type of setup, parallel or perpendicular, is not going to change, right? So you notice I got some of the same stuff on the screen. The only thing that changes are my numbers, right? So as I go ahead and try to hit a similar question, we're going to approach this again, right? So we have a new coordinate point. Our x1 is 2, our y1 is -3, and my slope here is 1/8, right? So now I know that my y1 is negative, so that means I'm gonna have a +3 here. My x1 is positive, so I'm gonna just put a 2. And my slope here is 1/8. A negative reciprocal of 1/8 will give me a -8. So then from there, I distribute my -8. So I have -8x plus 16, because a -8 times a -2 will give me a +16. I subtract 3 from both sides, and then I'm left with y equals -8x plus 13. So then I go ahead and type that into the dialog box. Y is equal to -8x plus 13 is our answer. And this is how you do parallel lines and perpendicular lines using the point slope formula.